A mole represents a number, 6.02 times 10 to the 23rd. It's a really, really, really big number, 6.02 with a whole ton of zeros after it. But just because it's such a big number doesn't mean it needs to be difficult to understand. A mole is a word like dozen. When I say you've got a dozen eggs or you've got a dozen rolls, you know that I mean 12. Well, when I say you have a mole of something, it means that you have 6.02 times 10 to the 23rd of it. Now, why do you think chemists would use such a giant number like 6.02 times 10 to the 23rd? Well, in chemistry, we count really, really, really tiny things like molecules and atoms. So we need a really big number so we can count that high. If you have 1 mole of any element, you have 6.02 times 10 to the 23rd atoms of it. 1 mole of an element also means you have that element's atomic mass in grams. So take a look at that periodic table and look at the atomic mass, and that is the number of grams of 1 mole of the substance. We use the average atomic mass from the periodic table. Look at your periodic table. You'll see the element symbol. Sometimes the name is written under it. We have the atomic number, but this number we're worried about right now. This is the atomic mass, and that atomic mass is in either AMUs, or atomic mass units, or in this chapter, we can think about it as being in grams per mole. So 1 mole of potassium, seen here, contains 6.02 times 10 to the 23rd atoms, and it has a mass of 39.1 grams. 1 mole of carbon, again, contains 6.02 times 10 to the 23rd atoms of carbon and has a mass of 12 grams. So, for example, we can look at the mass of 1 mole of calcium sulfate. You're going to have to take out your periodic table in order to do this one so you can find the molar mass of calcium sulfate. So let's look here at calcium. Calcium has a molar mass of 40.08. That's in grams per mole. Sulfur has a molar mass of 32.07. Again, grams per mole. And finally, oxygen has a molar mass of 16 grams per mole. But we don't have just one oxygen atom. We have 4 oxygen atoms. So we need to multiply this number times 4. 16 times 4 is where I'm going to start, and I get 64 plus 32.07 plus 40.08. This gives me a total of 136.15 grams. That is what we call the molar mass of calcium sulfate. It is the mass of 1 mole of calcium sulfate. If you have 1 mole of any molecular compound, that means you have 6.02 times 10 to the 23rd molecules of it. If you have 1 mole of any ionic compound, you have 6.02 times 10 to the 23rd formula units of it. The only reason I mention this is because people will sometimes call ionic compounds molecules, and sometimes this gets confused, but a molecule is something that is a true molecule between covalently bonded nonmetals. So let's take a look at this example. 1 mole of NaCl, or sodium chloride, equals 6.02 times 10 to the 23rd formula units of it. Now that equals 58.5 grams. I get that from adding the molar masses of sodium plus chlorine on the periodic table. This is also known as the molar mass. There's one last conversion I want to tell you about, and that's volume. If you take a look at moles and volume, You'll learn that gases have different molar masses, but gases all occupy the same volume. 1 mole of any gas at standard temperature and pressure occupies 22.4 liters. This is how big 22.4 liters. This wooden cube is about the size of 1 mole of any gas. Now, they go out of their way to say at standard temperature and pressure. Standard temperature and pressure is 0 degrees Celsius and 1 atmospheric pressure, because we know that if we change the temperature or the pressure, it will change the volume of the gas. So here it is, all summarized into one nice and neat table. And you will see all roads lead through the mole. 1 mole equals 22.4 liters of any gas at STP, or standard temperature and pressure. 1 mole equals 6.02 times 10 to the 23rd particles. So 1 mole equals 6.02 times 10 to the 23rd atoms, or 6.02 times 10 to the 23rd molecules, or formula units. And finally, 1 mole equals the molar mass of the substance in grams, and that's found on the periodic table. So let's do some examples. This says, what is the mass of 3.4 moles of calcium sulfate? What we have to do is we have to go back and remember what our molar mass was for calcium sulfate. We found that the molar mass for calcium sulfate was 136.15. We found that from adding calcium plus sulfur plus oxygen, 4 of them. So 1 mole of calcium sulfate equals 136.15 grams. But that's not what it's asking me. It's asking me what the mass of 3.4 moles are. So 3.4 moles of calcium sulfate. I can now use a conversion factor, like we learned in dimensional analysis. This table right here shows you all the conversion factors I might need to use. In this case, I am going from moles to mass. So the conversion factor I need is for every 1 mole, it equals the molar mass in grams. So I'll write that in there. For every 1 mole, or 136.15 grams. Now when I plug this into my calculator, I multiply all the numbers on the top, divide by the numbers at the bottom. You can type in 3.4 times 136.15, and you get an answer of 462.91, and this is in grams because moles cancel. Here's another example. How many moles are in 67.2 liters of CO2? This conversion factor is found right here. For every 1 mole, that's equal to 22.4 liters. 67.2 liters, and I know that for every 1 mole, that's equal to 22.4 liters. The liters will need to cancel out, which is why I know to put liters on the bottom. In my calculator, I type 67.2 divided by 22.4. So I get an answer of 3 moles. Now for the next one, we're going to go through 2 parts of the map. This says what mass of silver chloride would be obtained from 3 times 10 to the 25th molecules. So in this case, I need to go from mass to molecules or particles. So I'm going to follow the map through the mole. See, all roads lead through the mole. You'll need to convert to moles first before you can end in particles. Before I can do this, I need to find the molar mass of silver chloride. So I'm going to need a periodic table. I can see here that silver has a molar mass of 107.87 plus chlorine's molar mass of 35.45. So in my calculator, I type in 107.87 plus 35.45. So I get a total molar mass of silver chloride of 143.32 grams per 1 mole. So I start my conversion factor, 3.0 times 10 to the 25th molecules. Now I know for every 6.02 times 10 to the 23rd molecules, that is equal to 1 mole. And I also just found out that for every 1 mole, silver chloride has a mass of 143.32 grams. Go ahead and put this into your calculator. It's going to be 3.0 times 10 to the 25th divided by 6.02 times 10 to the 23rd times 143.32. You multiply everything on the top and divide by everything on the bottom. You get an answer of 7,142 grams. That's how much that many molecules are going to weigh. This is a similar example, except in this example, we're going the other way. We're saying this time that you have 2.5 grams of H2O, and we want to know how many molecules that is. Now, the molar mass of H2O is pretty easy. Hydrogen has a molar mass of 1, and there are 2 of them. So I just do 2 plus the molar mass of oxygen, which is 16. I get a molar mass of 18 grams per 1 mole. Again, just like I did in the problem above, I know that for every 1 mole, there are 6.02 times 10 to the 23rd molecules of it. Now, people might ask, why was it on the bottom last time and now it's on the top? You need to make sure whatever you do in these problems cancels. Molecules cancels, moles cancels, and you're left in grams. In this case, grams is going to cancel, moles will cancel, and I'm left in molecules. So you're going to change what side of the equation it is depending on how you're solving it. I type in my calculator 2.5 divided by 18 times 6.02 times 10 to the 23rd. And I get an answer of 8.36 times 10 to the 22nd. And that is the number of molecules that are in 2.5 grams of water. And that's it. That's the mole. You can go through and do some practice problems on your own.